Hi, in this video we are going to continue working with the template that I've created for FRC Robotics, and we're going to add our sensors, continue adding sensors to our ball shooter simulator. And so let's get started. Before we get started programming, I want to show you some environmental settings that you can use to help avoid some of the problems I have seen. So I'm just going to create a new VI here and just drop a numeric control on the front panel, and then I'm going to go to the block diagram, and you see that different than you've probably seen in my videos, your VIs may create these larger icons for terminals, and also if you create an indicator, create them as well. So that's one issue. I'm going to show you how to fix those so that we can have it create the smaller terminals. The other thing you may see is you'll be wiring. I'm just going to grab a converter. You'll be wiring, and all of a sudden, this feedback node will just appear out of nowhere and mess up all your code. LabVIEW sets these as icons and will sometimes put feedback nodes in your code when you don't want them. And there's some settings that we can set to avoid this from happening. So if we go to Tools, Options, this Tools Options allows you to set up the LabVIEW environment the way that you want it set up. And the two that I want you to uncheck if you want your programming to be similar to mine would be this first one, where we don't want to place front panel items as icons. We want them as the smaller terminals. And then the fourth item here, uncheck the auto insert feedback node in cycles. So then these feedback nodes won't automatically appear. You'll have to actually put a feedback node in manually for them to appear. I'm going to click OK, and now if I put a new control on the front panel, you'll see it goes as an icon, and if I try and do some feedback stuff, you'll see I'll just get broken wires that I'll have to fix. Alright, so set those two options again, Tools, Options, go to Block Diagram, uncheck the first one and the fourth one. So if you want to get the code we will be working with, if you go to this bit.ly link here, you'll go to my Google shared drive, and you'll want to download the Demo 1 2018 ball shooter, which was the code we completed in the last video. And then you want to unzip it and put it in either your desktop or the folder you're using to store all your projects. So I'm going to copy my Demo 1, and we're going to make a Demo 2 folder. Call this Demo 2. And we're going to go inside and under the RoboReel folder and open the project, and we're going to rename this project to Demo 2. So now that our project's open, we're going to do a file save as, rename, and call it, so we're going to call it Demo 2. Okay, so let's go to open our RoboReel project and go to our systems, and you see that from our previous videos we created this game controller. But one thing to note is we have some items in our library that we're not using and we don't intend to use in the future. One of these is the global command. Because of the game controller doesn't take commands, we don't need this. And then there's a cluster here also that refers to a command. So we're going to remove these two from our library because we may want to reuse this library or copy this library and not want to bring along these unneeded VIs. And I also want to show you kind of techniques or ways to remove files from the project. because it's usually a two-step process. So let's find where this VI exists. We'll start with this one. We'll start with the global. Let's find where this global exists in Windows. So we click on the project, and if we hit Control E in the project, it will open the Files tab here and show us in Windows the complete structure of where this VI is located. It's on our desktop. And then if you wanted to find that, have Windows show a Windows window that has this on it, we can right click on that device and do Explore, and Windows will open a window showing us exactly where that is. Alright, so the first option is we can just go find it in Windows and delete it. And then if we go back to our project and we go back to our items, we'll see we get this in our project. It says, well, there used to be something there, now it has been deleted or renamed and I don't know where it is anymore, which is fine because we did delete it. So we can right click on that and we can say remove from library. You can click OK and it goes away. So the second method that I like to use is I want to relocate it. I may not want to delete it. I may think, oh, I may come back and use this again someday. But for right now, I want to get it out of here. So I'm going to open up this item that I want to discard, and I'm going to file, do a save as, rename, and I'm going to move it to a new location. So usually I create somewhere on my desktop. I have a trash folder, so I'm going to I usually name it, put XX or something there. You see that I've already practiced deleting this. And then I'm going to close it, and then it'll be here in your library with the XX name, and that usually indicates to me that I wanted to get rid of this, and then we can also remove it from the library. And then save, and then everybody gets updated as well. Okay, so we've cleaned up our game controller library, and one of the reasons I want to do this is because the distance sensor, or the sonar sensor that we're going to build a new library for, is going to be very similar to our game controller, and we're going to copy that. We're also going to create a library for our gyro sensor as well. So I'm going to open up Robot Main from my project, and I'm going to go to the block diagram, and we're going to go down here to time tasks. Periodic tasks is what it's called. And we're going to see that here's the code that's going to read my sonar sensor. It's the distance sensor on the front of the simulated robot. And notice that it rounds the value to the nearest integer and then subtracts 14 from it. And we'll show why it does this when we get to the simulator. And then we store this in a network variable, probably for the dashboard to see. And here's our gyro, reading our gyro angle, and then we do some math on it to make it go from plus or minus 180 to 0 to 360. And then we take that value and again send it up to our dashboard using a network shared variable or network table. Okay, so let's start off and let's make our sonar library and create a loop and put it up here in time tasks with our sensor loop. So let's go back to the project, Control Shift E, and let's copy our game controller. So we're going to right click, we're going to say save as, we're going to create a copy, and we're going to call this sonar. Add it to our project, continue, and we're going to put this in our systems folder. We're going to create a new folder called Sonar and open that folder up and say use current folder. Then we have our Sonar folder. So the first thing we do is set our icon. I'm going to edit the icon. I'm going to use a black background with maybe cyan background. And then I'm going to choose this box and just draw a box here and get some text, make the text black, and let's just say Sonar. Use my arrow keys. There's my icon and click OK. Alright, I'm done with that, so I'm going to click OK. It's going to ask me to apply this Sonar icon to all my other items. I say yes and save all. Okay. So now we're going to open the sensor loop. And you see that sensor loop has the icon for my sonar. And we're going to do some very similar code to our game controller, but we're only going to have do one distance sensor because there's only one on the robot. So we're going to eliminate this reference 1 and this item in the cluster. Right, and I'm going to go and replace this with the WPI library. It's in Sensors, Ultrasonic, Sonar, Open. And you see the only choice we have is the SRF04 Digital Open. And there are two inputs that we need to say what is our ping input and what is our echo channel input. And I'm going to go back to my project and remember this README file. If I open the README file, it tells me my SRF04 ultrasonic sensor ping is DI1 and echo is DIO2. Alright, so I need to set ping is DIO1 and echo is DIO2. Alright, I'm going to create a constant here to add, so it adds to my cluster. I'm going to create constant. And if I double click on the edge, it will shrink it down to an icon, so it's manageable. And remember, I always got to add in a label to any constant I create here. And I'm going to replace that with my previous controller reference. Wire it in there and select it up here. Okay, so now I've had my ultrasonic reference. Let's go over here and replace the close. We're going to delete both of these. And we're going to select our new ultrasonic reference. And I'm going to select it, or go WPI library, sensors, ultrasonic, close. And then file, save all. Okay. And then the part in here where we're actually going to read the sensor, I can delete all this code because we have a lot less to do. And I'll delete all this and bring my... And then if I have a whole bunch of wires, instead of double clicking on each one of these, I can hit Control B and it will remove all broken wires. So I can shrink this guy down. We can grab our reference, and we need to bring this reference in. We don't need this guy anymore. So if my read enable is true, I want to read the range. So I'm going to go back to my WPI library. I'm going to grab my sensor and get range and wire that from my reference and back to my reference. Okay, so the data coming out of the range is going to be a double floating point value. So I need to come back to my cluster here and create a sensor double floating point value. So I don't need any of these arrays that came from the cluster, so I'm going to delete all these. And I see I have a whole bunch of broken wires, so I'm going to go back and do Control B. And then I'm going to shrink these up. I see here I have a sensor output double. I didn't use that before, but this can be our range out. And I'm going to, again, file, save all. And go back to our output here and get our range out and wire that in as well. And then we need to set up our global variables. Okay, so here's the global variable. We find that in the project. We just want to open front panel. Again, we can control Shift E. This is our sonar global sensor data out. So this is the data that this sensor loop writes. So one of the things that all sensor loops write is the cycle time. But we're going to change its name to sonar, sensor sonar cycle time. And I'm going to copy this because we also want a sensor sonar range. And put parentheses to say that I want it in inches. It's going to be in inches. And then all these other ones from the game controller, all these arrays we're not going to use in our distance sensor, so we can delete those. So our sonar sensor global, and all of these are named so that we know who the writer is. We know it's the sensor sonar loop writes the cycle time, and sensor sonar loop writes the range in inches. We save that and close this. We can go back to our sensor loop and select the right one, cycle time, and I'm going to drag copy, hold the control key, drag, and I'm going to make this my range, and I'm going to wire that. And file, save all. Okay. One other thing is, if you remember, if we go back to time tasks and we look at how they did the range finding, they rounded the value and then subtracted 14. So I'm going to copy this code and put that in my code. So I'm going to drag a box around it, the code I want to copy, Control C for copy. I'm going to go back to my sensor loop, and I'm going to Control V, paste, and then I'm going to delete. And I'm going to round it to the nearest and subtract 14. So that the range that I'm seeing will be the same range as they showed me in the demo. And then if read is enabled, so we're going to put in a number that tells us that it's disabled. So I don't think that we could get a negative number. So if I put -1 and I see that the range is -1, I'm going to know that something disabled my range finder. Something in the state machine disabled it. And we may later want to be able to disable our sensors because we're not ready, or the robot's in a bad state or startup, or we may want to do that some in the future. All right, so that's a sensor loop, and we're going to put this in time tasks. So go here to time tasks, and another way to transfer one VI to another block diagram is you can grab the icon here and we can drag it over like so, and now I have a sensor loop. And now what I want to do is go through and remove all the sonar code from the demo, and because now we're doing the sonar sensing in our loop. So I'm going to delete this code here. I'm going to leave this distance sensor because we're going to actually read it from our global variable. This still may be useful. So I'm going to Control-Shift-D, go to my project. I'm going to bring in the global sensor data out, and I'm going to change this to a read, and I'm going to select the sonar range. So the sonar range is going to be generated inside of this loop, and this loop is going to read the network table that's going to send this data up to the dashboard to be used. Okay, and now we need to go through and remove all the other WPI library VIs that call the sensor. So I'm going to right click on time task and do find all instances, which should take me to robot main. Okay, it does. And remember, there's WPI library stuff in Finnish sometimes. Okay, so no code in here that's doing the close. We can look in begin, and there's the sonar. We're going to delete that. And we need to look in teleop to see if that's happening. So I'm going to, again, right click here and say find all instances. It'll take me back to the robot main. Let's go into teleop and see. I'm going to go to teleop enabled. All right, I don't see any VIs, sonar VIs in teleop, and we already did time task, so I think we've eliminated all of them. Okay, so we've removed all of the WPI lib sonar VIs that were in the original demo, and they all now exist here in our sensor loop. So let's open our sensor loop, and let's go to our block diagram. Let's kind of review what we have here. Shrink this down so we can see things. All right, if we go back to our left, so for review, this is where all the data that we're going to bundle into our cluster. We're going to check the names here and make sure that the sensor input, again, we don't have a sensor input, so we actually can delete this. And I'm going to right click in here and say remove input. All right. We have a cycle time, we have a range out, and we have the read enable, so those are all used. Grab our times, calculate our cycle time. Our state machine is the same as our game controller. We have a startup, enable, and shutdown. And then our actions are the same as well. We have no action, reset time, read enable and read disable. And the state machine runs the same as the game controller. And then we get our ranges. If our read is enabled, we get our ranges, subtract by 14 for an offset, and then save our range out and write the range to sonar range to our global variable. So since we removed the sensor input, we're going to delete this as well. And cycle input, we're going to just name this range out, or just range. And that range should be in inches. Okay, so let's go look on our front panel. Control E. We're going to look on our front panel of this device, of this VI. So there's our range and there's our cycle time. Okay, we're going to minimize this, and then we're going to bring up our driver station. Showing this up here in the right corner because I want to watch my robot as it gets closer to the wall. I expect the range to go down, and then when I run into a wall, I expect that to be 0. So we are going to find the robot main, and we're going to run that. Bring up. All right. So I'm going to zoom into the robot here, and I'm going to enable the robot, and I'm just going to rotate him around 180 degrees so that we can see. So you see this, that little white thing on the end right here where my cursor is, that is the sonar sensor. Zoom in a little bit. So just one thing in using the in like moving things around and panning around on the simulator, if you just click and drag, you will kind of rotate the objects around. You have to shut off the follow. But if I hold down the shift key, you see I'll get a magnifying glass, and then as I drag forward, I zoom in, and as I drag backward, I zoom out. And if you hold down the control key, you can actually pan the view up and pan the view down and left and right. I'm going to pan up, and I'm going to zoom in here. Pan up some more, and zoom in. So this white thing right here, that's the sonar sensor. And you see the sonar sensor sitting on the frame of the robot, but our scoop here that brings the balls back in is sitting out further than the sonar sensor. So the reason that if we go back to our sensor code, Control E, and shrink this down just a little. Remember, we took our current range and we subtracted 14. So what we want, or what they wanted, was they wanted to know what the position of our scoop was. And that looks like it's 14 inches, like the sonar sensor is 14 inches back from the scoop. So the value that we're getting here is actually the distance the wall is, or whatever's in front of us, is from the scoop. Okay, so let's test that out to make sure that that is true. All right, so I'm going to minimize the sensor loop, and I'm going to actually close the simulator and then open it back up. So that the robot resets, and let's zoom into our robot here, and we'll go back to our driver station and enable the robot, and we will drive it forward. We're watching our rangefinder, so 143 seems to be the max. If it's further away than 143 inches, it will register 143. So that's something to note. As we get closer, there's 140. Now we're starting to get in range of our rangefinder. Getting closer. And then right about the time we hit the wall, so we see 76, and it looks like my rangefinder is actually looking in through that hole. If I come over here to the right, so I'm about 132, and if I look all the way to the left, about 125. So I could actually orientate my robot based on looking at the left and right wall to see where I am on this wall. So if I wanted to be close to the center of the big target here, looks like I could come in about 12 inches and then rotate and then shoot, and I might be on target. But you see, as my scoop hits the wall, I'm really close to zero, right? So that's why we want that 14-inch offset, because we want to know where our scoop is at, not necessarily where the sensor's at. Okay, so we'll play more with that later. So then the next thing we want to do is let's build the gyro loop. So using the distance in the gyro, we'll be able to use those sensors and maybe help autonomous or our driver tell us what direction we're facing and how far away from distance and objects we'll be. Alright, so let's close down our simulator, and we'll close down our sensor loop, and we'll get ourselves back to the project. Control-Shift-E. Alright, so we have a sonar loop now, and a library, and a game controller library. So let's make a gyro library. So this time we have the gyro library, and we want to let's copy the template this time, because we want to actually use the gyro reset in our code, which is a command that will come from one of the commanders. So we don't want to copy the game controller this time. Let's just use the system sensor template. All right, and I'm going to go through this pretty quickly as it'll be review. I may even speed up the video, and then when I get to adding the reset, we'll slow down and explain more. So I'm going to copy, save as, call this gyro. Put in our system loop, system folder. So now that we have our library created, I'm going to challenge you to now that you've seen me do the sonar and do the game controller, I'm going to challenge you to create your own gyro loop, fill in all the global variables, put in the WPI library VIs into that loop, and just let's go over a few things before you do that. One, make sure that you put in all this math as well into your loop. That changes the -180 to 360, and go back to begin. When you do the open, make sure that you open AI1 or use AI1 as they did here as well. Okay, so I'm going to pause it. I'm going to build the loop. I'll come back when I've created the loop and to see how you did. Okay, so that was done pretty quickly, so let's review. So I created the gyro open and created a constant, bundled that into my cluster so that I have the gyro references in my cluster. In this section, I added a gyro reset input so that a commander, either teleop or autonomous, can send and reset the gyro to 0. So I'm going to open this up and just show you just a button, just one button that any commander can set to reset the gyro, and we'll implement this in a little bit. Save. I didn't do anything at this time with the states and actions. We'll discuss those in a moment. And here when my read enable is true, I run the get angle from the gyro, and I put that into my cluster, and I also write that to my global variable. Global variable is set sensor gyro angle so that I know who the writer is, and I corrected and fixed this one, sensor gyro cycle time as well. And then at the end, we're closing the gyro once the loop stops. And one more thing to do is we're going to label these indicators on our front panel. Control E. We're going to label them so they make sense. So I'm going to label this just angle. And this is going to be where my reset is pushed. And move them so that a little bit. And I'm going to save file, save all. Okay, so we have all the basics of our state machine in here. Let's talk about how we're going to do the logic of our state machine. So we're going to go to my block diagram, and we'll scroll up here, and I created just kind of a diagram here of what I want the state machine to do. So if you want to create your own state machine on your block diagram, let me show you how to do that briefly. So if I bring up the front panel, on the front panel palette, there are decorations here, and I just took a decoration from the front panel palette, and if you hold Control key, it'll keep this. I'm sorry, hold the Shift key, it'll keep the circle. And then if you Shift right click to bring in the paint tools, you can right click and you can create a circle. And then I just double clicked and created free labels and just set them inside. And then also from the front panel palette, you can grab arrows to kind of point to things. And then the pink, I just Shift right click, grab the paint tool, and just painted them pink. So that's how I created each of these items here, and you can put them on your block diagram. You can also take an image, like draw your state machine on a piece of paper, take a picture of it, and then you can actually paste the image right here on your block diagram, so you can come back and refer to it. So I went through and decided this is how I want my state machine to look for this sensor loop. So I have a startup state, I have a disable state, an enable state, and a shutdown state. And then my actions are to read disable, read enable, read angle, and reset gyro. Actually, I want to call this get angle. Okay, and you'll see in order to do the reset gyro, the reset command, we have to see a rising edge on the reset command equal to true before we will go reset the gyro and come back to enable. And the get angle, we just keep doing over and over as long as we're in the enable. When our stop global is equal to true, we switch to the read disable action, and then we go into shutdown. Okay, so let's kind kind of implement this. So first, let's make sure that our states, we have our 4 states in our state enum. So go down here to our state enum. We should have startup. I have a reset, enable, disable. So let's clean this up so that we only have start, enable, disable, and shutdown. Yours may look different as I was playing with this previously. So I'm going to open TypeDef. I'm going to right click and edit items. And I'm going to decide that I don't need a reset state, and I'm going to delete that. So we want, at the end, we want to start up, enable, disable, and shut down state. I'm going to click OK and apply changes and save all. Okay. And then see, we have a broken arrow. We can go as we change that. Some of these had resets, and so we have to right click and review and update the TypeDef. And I'm just going to prove everything quickly for now because I'm going to change everything and fix it. And then if we go back up to the state machine, the actions that we have are read disable, read enable, get angle, and reset gyro. So let's create those actions in our enum. Advance or open TypeDef and edit items. No action. Reset time, we'll keep those two. Reset disable, we don't want. We want to reset gyro. I want to read enable and a read disable. Okay, so those are the actions that I want right now. Click OK, file, apply changes, file, save all. Alright, and then we can see what our issues are. Some case structure issues that we'll get to these. So let's go to our states here, and we make sure that we have a case for every one of our states. Startup case, enable, disable. Now we have 2 enable states, so we're going to have to get rid of one of these. Delete this. So disable, enable, and shut down. So there's our 4 states. And you see that we have some issues with our, because we changed our actions around. We need to find one that's grayed out, review and update. And I'm just going to approve everything because I'm going to come back and fix this. Anything in red we can delete. Delete this case. Alright, and let's check and make an action or make a case for every action. So no action, reset time, reset gyro has an action, read enable has an action, and read disable has an action. Okay. So we have a state, we have a case for every state and a case for every action. So let's start in our state case. So we look up here, startup case, we immediately leave and go to disable case. So down here, disable will be our next state. And we call read disable. So we call our read disable action. Okay, that's good. We go to our disable state. Disable state, we immediately go to read enable. I don't want to look or do anything, so I don't need any of this logic. I'm going to delete it. I'm not going to unbundle anything. I'm just going to create a constant off of this and we say go to enable. And the action that I want to do is read enable. So I'm going to create a constant off of this as well and say read enable. Expand it out so you can see that. I'm going to grab both of these, hold down my shift key and drag just to give them a little more room. Okay, and now we go to our enable case. So for my enable case, I need to look at my reset command and see if I have a rising edge. And that's what we'll do first. Okay, so to get a rising edge, here we are reading the gyro reset value. But to see a rising edge, we want to know previously was it false and currently is it true. So that would detect that we have a rising edge. The reason we want a rising edge is because if whoever the commander is sets the reset to true, and it's true all the time, and all we do is look at true or false, we could be resetting the gyro every iteration until the commander decided to shut the reset off. But really in true life, we just want to reset the gyro like once, and then after that we want to continue to read the angle, and we just want to zero it out when we do the reset. Okay, so like I said before, to see a rising edge, we have to say the previous value was false and the current value is true. So here's our current value. Now we need to record the previous value. Well, to record the previous value, we need to create a new item in our cluster, and we're going to call that previous reset. I'm going to take this one and I'm going to control drag. I'm going to copy, and I'm going to label it previous reset. Okay, and we're going to bundle that in here. All right, so like we did with our time, we're going to do the same thing. Here's our current time, and then we took our current time from the last iteration and we put it in previous time. And that helps us here to calculate our cycle time, right? We take current time minus previous time, tells us how much time has elapsed during the cycle. Well, if we take our, if we do the same thing with our reset, so I'm going to bring up unbundle by name, and I'm going to read the reset value. All right, I'm going to get rid of this so it stays out of the way. So the reset from the previous iteration, and I'm going to put that in previous reset. Okay, so now I have in my cluster, I have the current reset value that the commander is sending me, and I have the previous from the last loop reset that the commander sent me. So when the previous value is false and the current value is true, I know they have just sent that command. That command has just been sent. It's gone from false to true, and that is when I want to reset my gyro. Then the next iteration, if the reset value is still true, the previous value will be true and the current value will be true, and I don't have a rising edge anymore. I have a always on. Okay, so now we'll go back to the enable, and now we want to go look at our state machine, and our state machine says reset command rising edge equals true. All right, and so I want to take my reset, and then I want to look at my previous reset value. All right, and one way that's a neat trick to detect a rising edge is you can actually use a greater than sign, because LabVIEW will assume numeric values will assume a true is greater than a false. Okay, it sees the trues as a 1 and a false as a 0, so it knows that true is greater than 1. So we can say if reset is greater than previous reset, then we have a rising edge. And we'll run this into our case structure. I'm going to delete these other values because I'm not going to use them. So it's just template code. Right, and I'm going to document my code or my case structure, this case structure. I'm going to right click in here, visible items, subdiagram label, and I'm going to say reset rising edge. Okay, and then we go up here. So when we do see our rising edge equal true, our action we do is reset gyro, and we come back to enable. Okay, so our state that we come back to is, or we set is enable, and the action that we set is to reset the gyro. Right, matches here. And the other action we do, we're actually going to get angle as well. So let's pull down our array and say okay, so I forgot to add a get angle in my actions, so let's go back and do that. Okay, so go back to enable. When we're in the rising edge, we reset the gyro, and we still want to get the angle, which should be 0. Okay, and this actually should be true, the true case. So I'm going to right click in here and say make this case the true case. All right, in our false case, I'm going to say no reset rising edge. We just delete this code, and so if there's no reset rising edge, we come back and we get angle, and we come back to enable. So we come back to enable state, create constant, enable, and create constant. We get angle. All right. Okay, if we go to our disable state, we already covered that one, and shutdown state, we stay in shutdown, and it says we don't do any action, so let's just create a constant and make that blank, or we can put a no action in there, whichever you prefer. Okay, so that's our states. So our state machine kind of helped us figure out when we call, what's our next state, and what are actions that we're going to call. And so in here we're going to do our actions. Okay. So this was one method that we used where we're actually writing our outputs, but now we created an action. I'm going to add case for every value. Now we actually have a get angle action. So as I defined it up here in my state machine, we should actually get the angle based when we call that action. So I'm going to move this code into here, and then I'm going to bundle it into angle out, and then angle out I'm going to write my global variable. Alright, so here we are going to, in order to get the angle, we need the reference. So I'm going to get the gyro development reference, and I'm going to need to put it back. So I'm going to need a bundle by name. Always wear the middle terminal first. Okay, then I'm going to move the get angle into this action, and you can drag it, but you'll see LabVIEW tries to bring all the wires along with it and makes it kind of a mess. So if you don't want LabVIEW to help you with the wiring, you can just hit the W key, release, and it will disconnect all those wires and just give you the VI. So we're going to do that in this case. So we're going to drag and then we click the W key to release all the wires. And then the other thing we're going to bundle here is we're going to get our angle out. Right. Now all this code over here can kind of go away because we've replaced this code with our actions. But we still want to write all our globals in this section as well. But you'll see I already have the angle out, so I can just connect it here. Okay. So now we have a get angle action, and we actually are getting our angle, and we now also have a reset gyro action. Remove this code and do the same thing. So this code is very similar to my get angle, so I'm going to delete this and copy the other. I'm going to delete this case, and then I'm going to go to my get angle, and I'm going to duplicate it, and then I'm going to replace, right click, replace gyro palette with a reset. It'll save me a little bit of time. I gotta get rid of the angle out, like so. And just check all my other actions. No actions, we do nothing. Reset time, we do that. Read enable, do this. Read disable, get angle, reset gyro. Okay, and we have all those actions in our state machine. And we have a white arrow. I'm going to save all. Okay, so the last thing we need to do is go back into our robot main and remove all the gyro WPI library VIs, and because now they're all going to be used by our sensor loop. And we also need to place our sensor loop in time tasks. So let's do that first. Let's bring up our robot main and open our time tasks and go to the block diagram, and we're going to drag our gyro sensor loop into our time tasks, and then we're going to go through and find all the gyro code. So one thing we forgot to do here is add this code to our gyro to convert the plus or minus 180 angle to 0-360. So I'm going to copy this code and I'm going to go back into my gyro loop, and I'm going to do that here in the get angle. Make some space for it before I paste it. Paste it right there, and from the get angle goes here and the output goes there, and then delete this. And we will save all. So now our angle out will be from 0-360 using this code. All right, and now we can come down here and we can remove. Okay, so we've removed all our the previous WPI library gyro VIs. So let's try and test. So I'm going to my sensor loop. I'm going to bring up my sensor loop's front panel, put it up here in the right corner so I can watch the angle. And we have the driver station here, and we're going to run our VI. Okay, so let's see, our angle right now is at really close to 360, and if we enable a robot and we rotate the robot, turn him, we should see our angle change. If we try and face this wall, should we get it close to 90 degrees? And if I turn it all the way around, we should get close to 180 degrees, somewhere in there. And if I face that other wall, we should be around 270. Like that. And if I come back, it should be between 0, somewhere around 0. I face that wall. 360 to 0. So our gyro is working as we expected. So one other thing we could test is our reset working? We could open the reset global variable, and if we could actuate that button, we could see if our reset is working as we expect it to. So while it's running, we can actually go and find our reset global. We can open that up and size it so it fits on your screen. And because nothing else is writing to this right now, I'm allowed to actually open up the global variable and change the value. So when I push the reset button, you'll see that this reset will go high because the gyro sensor loop is reading it. But if I were to keep it high and we didn't do that rising edge thing, then my angle would always stay resetting at 0. Okay. But let's prove that that's not the case. Let's turn on the gyro reset. You'll see that it reset, and then as I turn the robot, slide this down a little bit so you can see. As I turn the robot, you'll see that my angle still changes. And if I bring this back, I have to shut it off and turn it back on again to get the reset. But it doesn't. It only works that one instance of the rising edge, and it doesn't keep affecting my angle. So let's do a little bit of debugging. Let's actually prove that's true and watch it happen. So I'm going to show you a feature called a probe, and we can use a conditional. It's called a conditional probe. It's very handy when you're trying to do debug. So I would like this is my sensor loop. I would like to basically when my gyro reset goes high, I would like to stop this loop, and I'd like to then walk through the loop very slowly to make sure that that reset happening actually does the things that I expect it to do. So you'll see while we're running, again the arrow's black, so that means that the code is constantly running. We have this little thing called the probe tool, right? And if I put a probe on here, it will actually tell me what the value of that wire is at real time. So if I go up here and I click true, see it goes true, which means that it read the true from the command reset global, and if I go false, it goes false. Okay, but I'd like to stop my code when that goes true. So there are things called what's called conditional probes. Okay, so instead of right clicking and putting a probe, I'm instead of left clicking and put it in probe, I'm going to right click and add a custom probe. And then there's this probe called conditional boolean probe. I'm going to add that one instead. So it'll still bring up a probe window with a LED, but if I go over here to the conditions tab, I can say pause if true. So I'm going to click this little true button. Now, if this probe sees a true, it will pause my program, which is very useful. Okay, so here, come up back to our global command, and I'm going to send my sensor loop a reset. So send it, and you'll see that my code actually paused, sitting there waiting for me. See that my pause button is red, and now I can execution highlighting, or I can step through my code little by little. So I'm going to execution highlighting, and I'm going to step. So there's the bundle. We're going to step over that, step over this, and you'll see my calculations, my loop calculations. You see I'll read my state and my previous state. I read the stop button. The stop button was false. So we go into our enable. I'm going to close this probe so that we can see a little better here. Then we're going to bundle our cycle time. I'm going to step over that. Now we get into our state case, and we're going to step into enable. Okay, so here's my reset. I expect to see a true there and a false there. So previously it should have been false because this is the first time I saw a true. So there's a true, and my previous is false, which means true is greater than false. It means I should generate a true and look at the true case. In this case, I will send enable as my next state. I will say reset gyro and get angle. All right, so we'll slide over here. I'm going to step over that, step over that, and I'm going to put my state and my previous state back into my cluster, step over that, and comes back and then now does the time. Now we are into our action loop, so I'm going to step into, so the first action I'm going to do is reset gyro, and you see we're going to do the reset gyro action, and step out, and then we're going to step back into the loop, and then the second action that we put in the list was to get angle, and so we go and we read our angle, we do our math on it, and we generate an angle out and put our reference back. So now we've completed all the items in that array, and now we broadcast our outputs. So we set our cycle time, and we put our cycle time in the global variable. We tell the front panel what our reset status is, and we set our angle to the front panel, and we set our angle to the global variable. And then we come back and we do the loop again. Okay. Now note, our reset is still true. So we're going to walk through this next loop, and we expect that now we won't continue to reset the value, because the current value, or the previous value, was true, and the current value is true. Okay, so true is not greater than true. Step through this really quick. Get into our state. We're going to step into our state. So true greater than true, that's false. We do not have a rising edge anymore. So all we do is we still set the enable state, but we only get the angle, and we do not do a gyro reset. See here, we only set the get angle, step into, get our angle, and so on. So I'm going to release execution highlighting and release the pause and let the loop run, because it's working as I expected it to. I got to step through it and test it and make sure it's doing what I expect it to do. Okay, and the next video we're going to build the drive code, and I'll see you the next time. Bye.